All right, welcome back. This is my actually uh, working directory. So we want to continue from where we stopped. That now that we have created our PCA, we have extracted the facial features from the dementia faces. Now it's time to process it using R. So I've renamed it here combined underscore coordinate dot TPS. So two of them are here combined. So you can see them here, right? So this is what I have now. Finally, what I have. So I rename it to this. Okay. The first set is a F fragile X. Okay. So, and second set is a Williams. If you scroll down, you see them here. It's William. So all is combined here. So I want to process using R. So let's go to our R section now. So the first thing you want to load is library. You have to install this geomorph first. If you don't have it, just install. You can say install dot packages. You know, call it geomorph. So you run this line, it will be installed. All right. I don't want to install because I already installed, so I just need to load. So if you have not yet installed, just run this line and it will be installed. Then when it's finished installation, then you can now load. I load the package, so I'm loading it now. It's loading. So don't mind the warning, so just ignore. All right, so it has loaded. Now I want to read my TPS file first. All right, don't forget. I have created. Don't forget, you have to first before you start. You have to first create your working directory in R. If you are new to R, you should know how to create working directory, and you have to create a folder. Copy this your file and put in a folder. Okay, the name is combine coordinate.tps, so not my combine. So don't forget this is uppercase, this C is uppercase, all right? So that, don't forget, see that it will cause a lot of problem if you don't name properly. So you have to check your name if it's correct. This is lowercase c, and this one is only this one is uppercase. You have to take note of that so that it will not be making error. So now I'm creating an object called lm, so it's just a variable name. So I'm now calling the function called readlan.tps. So this is why I pass in my name, the name of the coordinate, the TPS file here, and I'll specify ID is equal to ID. Don't forget, if you remember last time I was explaining that you could use image. So if I'm using image, I'll say image here, but now I didn't specify image when I was creating it. I use ID, so I have to specify ID here. Don't forget that. I don't know if you still remember what I'm trying to explain last time. If you open it again, you understand what I'm saying here. I specify ID here. Okay, see ID equals to, if I say image here equals to this, I have to use image here also in my R. Okay, here specify ID. Okay, so take note of that. Now if I run this line, it should be able to run. It has run, so telling me no curve detected, all points appear to be fixed last mark, which is correct. So don't mind the warning, just telling me not all specimens have scale adjustment, perhaps because they have already been scaled, which is correct. So we don't need any scale adjustment. So now I want to compute GPA. Okay, I've assigned my this to L now LM, so it's already as run. So I want to compute my GPA, general Procrustes analysis first. All right, so this I create another object called lm.pro, then I call a function called GPA gen. So I assign my landmark here. I don't want to see the progress. If I remove this, I can see the progress to be showing step by step to 100% how it's computing. I don't want to see the progress so that I'm not wasting my time. So I just say progress equal to false. All right, so I run this line. That's finished. If I didn't off the progress, it will be giving me 1%, 2%, 3%, 4%, but I don't want to see that. Okay, so I have to off it. Then you can see you can plot and see the our GPA how we do. Let me just like this so that I can see. All right, so let's run this line now and see and plot and see what I'm talking about. You can see how it look like. Okay, this is a structure. this is called general Procrustes analysis structure. So you can see your GPA how it looks like. So this is structure of our data set. All right. Okay, so this is how it look like. Now we can now run the summary on this if you want to run summary, right, on this one. But we don't need it. We don't need it. So just to show us the coordinates, right? Okay, show the coordinates of this particular one that we are. This is called this consensus now. This consensus or that is called the mean configuration. This is what we just saw now of everything, all the landmarks. That's what it's showing us here. Right, but we don't need this actually. We don't need this. All right. So we want to compute our GPA, which is our principal component analysis. So we say gm.proschool print component. So that's what our function are going to use. Then we pass our lm.pro that we created just now. Okay, for GPA we pass it here. All right, as dollar coordinate. We want to because if you run this now, if you run this line, okay, if you say, let me say, if you say that lm.pro, it has many, if you dollar sign, you can see it has many other things. It has a coordinate, it has a centros, a size, iteration, consensus, and the rest of them. Okay, you can see we have so many things, but what we need from here is coordinates. All right, we need coordinates. So if you run the coordinates, you see all the coordinates of the file, which you can also save back to your disk. All right, if I run this line now, to go to show me all the coordinates of each of the specimen one by one, right? You can see now, you can see them, you can see them. So I don't need that. So now I want to compute the GPA on them, on the coordinates now. So on this coordinate, so dollar coordinate, take note of that. So we now run this line of code. GPA is computed. Now we want to see the scheme plot of the GPA, all right, of the PCA rather. So we want to see. So you can say bar plot PCA dollar, because inside the PCA, if you write, if you say PCA also dollar sign, if you are used to R, you can see that automatically you see some other variables display here. Okay, you can see rotations and deviations, rotation, scale, center, and the rest. So what we need is SDF, okay, and X. But okay, so if I run this line now, just say PCA dollar this square, this is square now, divided by sum of PCA plus this square to give me this. Okay, give me the script plot. Okay, this is script plot. This is a script plot now, right? Script plot. So compute 172. So all of them are here actually. Components. If I zoom, if I expand, you can see. So something I see they are still hidden here too, because there are many of them. So you cannot see all of them at a glance. That's why it's showing me about them. So you can see them here. So see. Okay, 1, 2, 3, 4. I think 4 is enough, or 5. So 5 is 5. Maximum is 5, which is good here. But we don't need that. Let us plot the. Let us see. Plot the PC. So it's a plot of the PC. The PC one is give us 34.88%, and PC two give us 24.98%, which is good, because the PC must not be too must not be concentrated on one particular PC, because this is a little bit spread now, which is good. But sometimes your PCA can concentrate on particular PC. So orthogonally, this is not correct, because it means that sometimes you can have PC1 to be 80%, 70%. All right, then because everything must be 100%, which means others may be having maybe 0.1, 2.2. So it won't be properly spread to just be concentrated on particular PC, which is not good. So, but this one is at least spread. 34% is good for PC1, and that means you can have more number of PCs that you can that have variabilities. So now we can summarize. We can show the PC result in there now. All right, just summarize the PC result. Okay, so you can see. So the PC result. So it's showing you the type of ordination, which is principal component analysis, centering. Okay, orthogonal projection of residual. The number of observation is 120, which is 60 for each. Number of factor is 60, which is point on the faces. Now we have eigenvalues, okay, and the proportion of the variance and cumulative proportion. Now this is the proportion. This is the proportion of the variance, okay, for one first for the second, right? So it means that 34%. That's what I mean. 34%, which is this one we saw here now. 0.88%. That's what we saw for the first PCA. 34.878, which is an approximation to 88. All right. For PC2, give us 24, 24.89. All right. Here, 24.8. 24.98 rather, 0.98 approximation. So that is how we are going to do the rest. But this cumulative proportion right now, 34. Okay, for the first one, when you add this one to this, you have 59.85. When you add that one to this third one, you have 73. That one 82. You continue adding them cumulatively until you reach to the 100% here. Okay, it's 100% now. This 100%. If you see that the numbers towards the end are very small, okay, we have 60 PC now. You can see this one is giving us 0.0000 something. 0.0000 something, 0.00. So their number are not minimum. Is 9 point something. So it's not. They are not good enough. All right. So we need to filter by confidence interval. So we want 95% confidence interval, for example, for feature selection. These are our features actually. We want to use, okay, PC is our feature. So this is PC1, PC2, PC3. Now we want to extract the PC out. So we want to make sure that our cumulative PC is 95%. So let's check that where we have 95%. Which PC is that? It is at the PC we have at the 7 we have 90, at the 8 we have 92%, at PC copy 9 we have 93, 10 we have 94, 11 we have 94.5, 95. So we can take to PC 11. Okay, PC 11 we have 94.5. So this is already 95.6 already. So let's say 94.5 is okay. I mean, this 95 this one can be applied to 95%. Right, this one already 95 above. You can take 11 or 12. Okay, 2 of them is okay. So you can just take 11 or 12. But let's save all the PC to disk first. Okay, don't forget our PC should not go beyond 12 now because our 95 computer interval is 11. Okay, 95% computer interval is 11. So our C high. Don't forget that if you want to use 90% confidence interval, you can use that one is here. All right, you can take. That means you have to take only 90. Want to take only 7 PC. You want to use 99 confidence interval, 99% confidence interval. You can use 99%. You are going to use how many PC now? I'm going to use a 26 PC. 26 PC. So this 99% confidence interval. All right, so now let's save to disk. Now if you run this line now, the PC will be saved to disk. Okay, all PC will be saved. We call it all PC. That's our name, PC name to CSV file. Okay, we save. It is saved now. So we can open our PC. If you want to save eigenvalue, you can do that also. All right. So we don't need to save eigenvalue. So that means $D, but our PC is $X. Don't forget $PCA $X. Our PCA. Our PCA file. So let's go and open the PC this is it here in Excel and see what how it look like. You can see. Look at all the observation name. F1, F01. This is fragile 60. Right, 60 here. Okay, and this is Williams. Let's see. You can see how. So this is how it's structured for us. This is so we have PC1 to PC 60. So we don't need all of them. We just want few. So we can just delete these ones. Okay, we can delete to PC 12. All right, you can delete this. Right. So you can now save this one as selected PC. So save as selected PC. Can save. So this we can work with this now. Okay, we can work with this. So these are our feature that we should use to classify. So these are features. All right, don't forget that. So, but we can see add something here. So because we have F, so here you can maybe add maybe let's say insert column. We have disease. You can call it disease. Okay. We are trying to we say fragile X. Okay. For the all the F now, we drag them down. Okay. This point, right? Then Williams. So now we can just click twice here to load it. Already loaded. So you can see. So this is our factor variable now, or target variable. All right. So we have features. Okay. Predictors. We have a target variable here. So we can remove this line. I can remove this ID. So this is ID actually ID, but we don't really need it for when it comes to machine learning, because I want to use this one to build a model. Okay, so we don't need this line, so we can take this off now. Okay, we can take it off. So this is what we have left. So this is what I want to work with now. All right, we only want to predict our disease. So to predict it, so we're going to use it to predict. So that is the next step. So the next class I will show us how to do that in a support vector machine, in the random forest, and in neural network. So I will see you in the next class. Thank you so much for listening. I will see you in the next class. So you can save this now.